This is AP Calculus 512, Exploring Behaviors of Implicit Relations. Remember, you usually use implicit differentiation when you can't get y by itself. And that would be the case in this one. It's going to be very difficult to get y by itself, so we would use implicit differentiation. So the example says, for the function 3x squared minus 3xy plus y squared plus 6x equals 9. Number one, find dy over dx implicitly. So that just means find the derivative implicitly. And if they ask you to find dy over dx, remember dy over dx, when I do differentiation or implicit differentiation, instead of writing dy over dx every time I write y prime, it just saves me some writing. Y prime and dy over dx are considered the same thing. Another thing, or another way they might ask you to find the derivative implicitly is they may ask you to verify that something is, in fact, dy over dx. So they could either ask you to find it implicitly or verify that something is true. The second thing we're going to do is find the equation of the line tangent to the graph at its x-intercepts. And then number 3, we're going to write the equation for the vertical tangent lines. Pause the video, write down these or this example, and then we'll go from there on the whiteboard. In part 1, we're finding the derivative of our equation implicitly. When we do that, we just take the derivative, and remember, anytime you take the derivative of y, you have to include a y prime. Y prime is the same thing as dy over dx. I just use y prime to save me a little bit of writing, and then I would put the dy over dx in at the end. To take the derivative, I have 6x. Here I'm going to use the product rule. I have a minus here, so that minus needs to be in front, and I'm going to put the product rule in parentheses so that I don't forget to distribute that minus sign. So the derivative of the first part is 3 times the original second, y, plus the original first part, 3x, times the derivative of y, which would be y prime. Remember, when we take the derivative implicitly, anytime we take the derivative of y, we have to include that y prime. That would end the product rule, so I put parentheses. I take the derivative of this, that would be plus 2y prime. And then we've got the derivative of 6x would be 6 equals the derivative of 9 is 0. The next thing we have to do is get y prime by itself. I'm going to distribute the minus sign. And then to get y prime by itself, I'm going to leave any term that has a y prime on the left-hand side and anything that does not have a y prime on the right. So when I do that, I'm going to keep this, the negative 3xy prime plus 2y prime on the left, and I'm moving everything else to the right side. So I've got a negative 6x plus 3y minus 6 on the other side. I'm going to distribute out the y prime, which would leave me with a negative 3x plus 2y equals my right-hand side. And then I'm going to divide by anything that is not y prime. Now remember, y prime is the same thing as dy over dx. So my dy over dx is equal to this, and I'm going to rewrite that to make it look nicer. 3y minus 6x minus 6 divided by 2y minus 3x. So that is my dy to finish out part 1. Part 2 of this problem tells me to find the equation of the line tangent to the graph at its x-intercepts. Now, we know from Algebra 1, Algebra 2, that anywhere we have an x-intercept, that would be where the original equation had a y that was equal to 0. So what I'm going to do first is I'm going to take my original equation. Anywhere that I have a y, I'm going to replace that with 0 and see what I end up with for my x-intercepts. So I would have a 3x squared minus 3x times 0 would be 0, plus 0 squared would be 0, plus 6x equals 9. If I solve that, everything is divisible by 3, so I would have an x squared plus 2x equals 3. If I set it equal to 0, I have an x squared plus 2x minus 3 equals 0. Factors of 3 that subtract to give me 2 would be a 3 and a 1. I would have a plus 3 minus 1. So my answers would be x equals negative 3 and x equals 1. So my two x-intercepts are at x equals negative 3 and x equals 1. We will use this information to answer part 2. It says find the equation of the lines that are tangent to the graph at its x-intercepts. So if we know the x-intercepts will occur when x equals negative 3 and when x equals 1, our actual x-intercepts are the points negative 3, 0 and 1, 0. So in the problem, they're asking us to find the equation of the line tangent to the graph at its x-intercepts. Okay, if these are the x-intercepts, and we're asked to find the equation of the lines, in order to find equations of lines, we need two things. We need the slope and we need an ordered pair. Well, we have the ordered pairs. Those are the intercepts. To find the slope, what we will do is we will plug each of these ordered pairs into the dy over dx. Remember, dy over dx is the derivative. Derivative represents slope. So if I have the full ordered pair, I can plug that ordered pair in for x and y to find the slope of the line at this point. So I'm finding the slope of the tangent line at negative 3, 0 when I plug it into the implicit differentiation. So I'm going to do that for negative 3, 0, and then I'm going to do it for 1, 0, find the two slopes that go along with these points, and then write the equations for their tangent lines. So if I plug negative 3, 0 in, I will have dy over dx is equal to 3 times 0 is 0. Negative 6 times negative 3 is a plus 18, a minus 6, over 2 times 0 is 0, and negative 3 times negative 3 is 9. So I've got 18 minus 6 is 12. 12 over 9 will give me a slope. Remember, dy over dx is slope. So the slope of the tangent line at negative 3, 0 is 4/3. So the slope of the tangent line here is 4/3. If I plug 1, 0 into the same equation, my dy over dx is equal to 3 times 0 is 0 again, minus 6 times 1 is minus 6, minus 6 again, over 2 times 0 is 0, and negative 3 times 1 is negative 3. So negative 6 minus 6 is negative 12, divided by negative 3 would be a positive 4. So my dy over dx, or I could write that as my slope of the tangent line at 1, 0 is 4. So now they ask me to find the equation of the lines tangent to the graph at its x-intercepts. If this is the x-intercept and this is the slope at the x-intercept, my equation of the line would be y minus 0 equals 4/3 times x minus x1, which would be a plus 3. There's the equation of one of those lines. The equation of the other line would be y minus 0 equals 4 times x minus 1. There's the equation of the second tangent line. In part 3, they've asked us to write the equation for the vertical tangent line. Well, we know we have a vertical tangent line when the slope of the tangent line is undefined. So, since this represents slope, we need to figure out when is this undefined. Well, it will be undefined when 2y minus 3x equals 0. So if we simplify this and get y by itself, wouldn't we have 2y equals 3x, so y equals 3/2 x? So if y equals 3/2 x, what I could do is I could plug this back into the original and figure out what my vertical tangent lines would be, because once I solve those for x, I would have x equals a number which would represent the vertical tangent line. So I'm going to replace everywhere in here, I have a y, I'm going to replace it with 3/2 x. So I've got 3x squared minus 3x times 3/2 x plus 3/2 x squared plus 6x equals 9. So now I want to solve this for x. So I've got 3x squared minus 9/2 x squared plus 9/4 x squared plus 6x equals 9. To make this a little bit simpler to solve, I like to get rid of my fractions. So I'm going to multiply this entire thing by 4 to get rid of the denominators. So if I multiply by 4, I have 12x squared minus 18x squared plus 9x squared plus 24x equals 36. So if I have 12x squared minus 18x squared, that's negative 6x squared, plus 9x squared would be a 3x squared, plus 24x minus 36 will equal 0. Now I can divide everything by 3 to make this easier to factor. So that's an x squared plus 8x minus 9 equals 0. Factors of 9 that subtract to give you 8 would be 9 and 1. And the 9 would get the plus, the 1 would get the minus. So we end up with x equals negative 9 and x equals 1 as our vertical tangent lines. In the next example, they ask us to find the points where the graph has a horizontal or vertical tangent line. We have to take the derivative of that equation implicitly. Remember, anytime you take the derivative of y, you need a y prime. Then once we get that derivative, we're going to set it equal to 0, and then we're going to see where it's undefined to determine the points where we have vertical or horizontal tangent lines. So if I take the derivative implicitly, I've got 50x plus 32y times y prime plus 200 minus 160 y prime plus 0 equals 0. I'm going to get the y prime by itself. So I've got 32y times y prime minus 160 y prime equals negative 50x minus 200. And then I'm going to take out the y prime. So if I do that, if I take out a y prime from each of those, that y prime is going to be gone, that y prime is gone because it's on the outside. So we have y prime equals negative 50x minus 200 all over 32y minus 160. So this is my y prime, or it's also known as the dy over dx. So that is the derivative. In order to figure out where this thing has a horizontal or a vertical tangent line. For the horizontal tangent line, we would set this whole thing equal to 0. Now, if you do that, the denominator is going to cancel out, leaving us with negative 50x minus 200 equals 0. So if that's equal to 0, that would be negative 50x equals 200. So x would equal negative 4. And then for the vertical tangent lines, well, I'm going to write that here. So for the horizontal tangent lines, that will happen when your x equals negative 4. For the vertical tangent lines, you have a vertical tangent line when the derivative is undefined. Well, that will be undefined when 32y minus 160 equals 0. Well, if 32y minus 160 equals 0, that will be 32y equals 160. So y is going to be 5 when we divide that over. So we have vertical tangent lines when y equals 5. Now, we haven't quite finished the problem yet because the directions said to find the points where the graph has horizontal or vertical tangent lines. So we need to take these values, plug them back into the original, get the other value. So for x equals negative 4, we need to plug in here and figure out what y is, set up that ordered pair or ordered pairs. Sometimes you'll get more than one. And then we'll plug y equals 5 in and get the x values and then set up ordered pairs for that. I'm going to plug negative 4 in for every x in my original equation. So negative 4 squared is 16, and 16 times 25 is 400, plus 16y squared. Negative 4 times 200 is negative 800, minus 160y plus 400 equals 0. So if I solve this for y, I have 16y squared minus 160y. 400 minus 800 is negative 400 plus 400 is 0. So we've got that equals 0. If I take a 16y out, I will have y minus 10 left. So y equals 0 and y equals 10. So we have horizontal tangent lines at the point -4, 0 and -4, 10. So this one gave us two ordered pairs where we have horizontal tangent lines. We found earlier that we have vertical tangent lines when y equals 5. So we're going to do the same thing. Everywhere there's a y, I'm going to plug 5 in. So I've got 25x squared. Y is 5, so 5 squared is 25, and 25 times 16 is 400. Plus 200x, negative 160 times 5 is negative 800, plus 400 equals 0. Then if I simplify this, I've got 25x squared plus 200x. 400 minus 800 is negative 400 plus 400 is 0, so that cancels out again. I can take a 25x out to factor this. I'll be left with x plus 8 equals 0. So I have x equals 0 and x equals negative 8. So the two ordered pairs where we have vertical tangent lines are at 0, 5 and negative 8, 5. And this one they've given me a differential equation, x squared plus y squared equals 25. And they ask us to find the equation of the tangent line when x equals 3. Well, if they ask us to do that, we're going to find the derivative implicitly. So that would be 2x plus 2y, y prime equals 0. If I get y prime by itself, I would have y prime equals negative 2x over 2y. So y prime is equal to negative x over y. So if they're asking us for the equation of the tangent line when x equals 3, what I need to do is plug 3 into my original equation, 3 for x. So I would have a 9 plus y squared equals 25. So y squared equals 16. If I take the square root of both sides, I have y equals plus and minus 4. So I'm going to end up with two answers. I've got y equals plus or minus 4. So when x is 3, I could have 4, or I could have negative 4. So I've got two ordered pairs. I could plug these two ordered pairs into my slope formula. So when the ordered pair is 3, 4, if I plug that into y prime, I end up with y prime equals negative 3/4. When I plug 3, negative 4 in for y prime, I end up with y prime equals negative 3 over negative 4, which is a positive 3/4. And then to find the equation of those tangent lines, I have a point and I have a slope for each of those. So I can plug into point slope form. So y minus 4 is equal to negative 3/4 times x minus 3. And for this one, y plus 4 is equal to 3/4 times x minus 3.